Did you access that one?
Yes, sir, I did, but I gave you my G Suite ID yesterday.
Yeah.
So you can add me in this section.
Okay, fine. I didn't add you still.
No.
Oh, I'm sorry. Then I'm going to add you after this class, right? Just give
Okay,
me a reminder after the class.
okay, sir.
And the second thing is that I also uploaded some suggested problem or problem solving session into your Bucks channel in lecture 1. There are basically the tutorial problem. That's called the tutorial problem actually. You can also access that resource from the Bucks. So because
Sir, are those quizzes are graded or just for practice?
this is although it's practice, but there are some marks. That's called the participationary marks. You will get the 10% for that
Okay.
if you just attend on that, because your attempt is unlimited over there, right? You can justify your understanding level. So try as much as possible. Actually, you can correct that one. If you just attend to that participatory quiz, you will get the automatically 10 marks. But you have to participate there. Unless you don't participate, you'll not get the marks.
Yes, sir, I did. I have, I think lecture 2, I did still have not completed the quizzes. Only I saw the videos.
Yeah, that's okay, because we are in, didn't go through the lecture 2, right? So lecture 2 basically, yeah,
Yes.
I'm going to do the cover the lecture 2 today. So you can do that after today.
Yes.
Hello, sir.
Yes.
Sir, do we have any reference book or any book that we have to go through?
Yes, we are using basically the Resnick Halide Walker 10th edition. That is Principle of Physics. The name of the book, this is actually, this is the 9th edition. So I'm going to show you. Sorry, it's taking time to load. This one? It's a
Not yet.
fundamental. Yeah, this is actually fundamental of physics. This is the 9th edition. This is the American printed copy actually. So we are going to use the 10th edition. The same book. There is.
See anything?
You can't see still.
No, it's
No,
just
sir.
a black screen.
No, sir. Not yet, sir.
Not yet. Okay, fine. So probably there will be issue for that bandwidth. So anyway, that book is basically that Resnick Halide Walker. That's available actually in our library, or you can also collect it from.
Sir, can you just write the book name in chat box?
Oh, sure. So give me 1 minute. So it's not working. I give that name of the book, Fundamental of Physics, 10th edition, Resnick Halide Walker.
Will this be uploaded in Box?
No, not really, because there is a copyright issue. We cannot do that. Soft copy, basically, if you need the soft copy, you can give me a mail. Actually, I can email you, but there is a copyright issue. We cannot upload into that website. Okay, fine. Now can you see my screen?
Yes, sir.
Yes, sir.
Okay, that's
Yes, sir.
fine. Okay, last class we talked about this thing, right? So we just resolve the vector in three-dimensional case, how we can express a vector in terms of three-dimensional using the vector triangle law. The only law I'm using over here, right? Only for the vector triangle law. Whether I'm going to adding, subtracting, or taking the component all, we are using basically using the vector triangle law. So right now, say I'm going to talk about today basically your properties of the unit vector. So and also the component, and we will also talk about the vector multiplication. These are the topic we are going to cover today. Fine. So let's first start the properties of the unit vector. Properties of unit vector. So for Cartesian coordinate system, we'll talk about this is actually my say that x-axis. This is actually say that y-axis, and this is my z-axis. Then I know we define the unit vector for Cartesian coordinate system. Along to the x direction is the I hat, along to the y direction is the z hat, and along to the z direction is the k hat, right? That's the convention they use over here. So we'll also follow that convention. Now say I'm going to take the product of this unit vector I dot I. What would be that? So although I didn't introduce the idea of the dot product and the cross product, but we are going to use that idea over here. I know all of you that idea, you know that formula. So if we take that A dot B, we use that. This is actually that AB cos theta, right? We know that formula where
Yes, sir.
A
Yes.
theta is
Dot
the
product.
angle between
Yes,
dot
sir.
product, definitely. Theta is the angle between the vector A and B. Similarly, for the cross product, we use A cross B is AB, magnitude of A, magnitude of B, and sine theta into eta hat. This, since it's a cross product is a vector, right? It has some direction. So that direction would be towards the direction of this eta hat. I use the eta hat, it's an arbitrary direction. I don't know which direction it would be. If we say if the direction is towards the positive x-axis, then I will use the I hat instead of eta hat. Since it's unknown, so that's why I use any arbitrary letter over here, eta hat. So the direction of this eta would be, must be perpendicular to both A and B. Remember this thing. I'm going to talk about this thing in the case of the cross product. But we are going to use that two properties to find out the properties of unit vector. If I use that one, then what would be that? I can write. So I'm not basically the give you to memorize this thing. I'm just showing you how it's become or where it's come from. This I know that I dot I basically the one, right? You know that one? I
Yes,
dot
sir.
I is basically
Yes, sir.
one.
Unit
Yeah,
vector.
how do we find out? Yeah, unit vector, definitely. So properties, how do we find out? Say I'm going to use that one. So I write down the I dot I, then I know that the magnitude, I'm going to show you where it's come from the one. Say if I write down, say the magnitude of I is 1, and the second one is also with the 1. And what is the angle between this I dot I?
Sir,
One,
0 degree.
So it's 0.
it's a 0 degree. Very good. Right? It's a two parallel vector actually. So this is I, and this is will be one more I, which is in the direction of that itself. So then I can say the angle is 0 degree. And cos 0 basically the 1, right? So 1 into 1, I am going to find out 1. So that's why we write down, say that I dot I equal J dot J equal K dot K. That is going to give you a unit 1. So that's would be the 1. This is actually that I dot I. If we take that the unit vector product of itself, that's going to give you the basically the 1. Fine. What about if I take I dot j, what would be that? I know
0.
the magnitude is with a 0, yeah. So I magnitude is 1, j is 1, but the angle between these two vectors is what?
90 degrees.
90 degree. And cos 90 basically the 0. So then I'll find out I dot j would be basically the 0. So that's when I can say I dot j equal j dot k equal k dot I. That must be going to be the 0 basically over here, right? So this is actually that. So that's mean if we take the dot product of unit vector itself, that's going to give me basically the 1 is going to be the survive. I say in that way. But if we take the dot product with the another unit vector which is perpendicular to vector itself, then the dot product is going to be the basically the 0. They will vanish each other. I explained in that way. Is it clear to you?
Yes, sir.
Yes.
Yeah, fine. So you don't have to memorize these things actually. I dot I basically the one. If you forget, then you can use that technique to find out that one. But this is very important properties. We have to use that one to do the dot product and the cross product of two vector, 2 or 3 more than 3 vector we can say. Fine. Now what about say if I write I cross I, it's a cross product. I'm going to use that formula to use that one. So what will be that? It's a 1
Sir.
into 1 and yes.
So please, the cross product, please, isn't it the magnitude of A dot
Yeah.
B is equal to?
Yes, this is the cross product. So I write down say A cross B actually. So this is the magnitude of vector A. This is the magnitude of vector B.
Okay,
Then
sir. Okay.
sine theta. Theta is the angle between the vector A and B. And this is the eta hat.
So,
Right.
so please, my question was.
Yeah, what is
Sir,
your
can
question?
So my
Sure, go
question
ahead.
was, the cross product of A and B will give us a vector.
Yeah, definitely.
So isn't the A and B like the magnitude equal to the magnitude of A multiplying B is equal to magnitude of A magnitude of B sine theta?
So I didn't get you, Albert. Can you say it again? Because it's sometimes it's lagging in your.
Okay, so from the lecture, I realized that magnitude of A cross product B is equal to magnitude of A times magnitude of B sine theta, which is the angle between A and B.
So you are saying that so magnitude of A equal, that is the magnitude.
Yes.
Yeah, you can say that. This is a
Okay.
magnitude A B into sine theta. Yeah, that's the magnitude you can find out because we can find out the magnitude of vector of any vector, right? In that case,
Okay,
you
sir.
don't have to this eta head actually.
Okay, sir. Okay, sir. Thank you.
You're fine. So if I want to use, then what is the angle between this one? I cross I?
0 degree, sir.
0 degree.
0 degree.
Exactly. Sine 0 degree into eta head. And sine 0 basically the
0.
0.
So that's why we can write from this idea, say I cross I equal J cross J equal K cross K is going to be that 0. This is that cross product of unit vector itself. That will give you 0 over here. So look at this, the difference between the dot product. If you take the dot product with the unit vector itself, you will find out the 1. But if you take the cross product of a unit vector with itself, that's going to give you the 0. Who is knocking me? Yeah, fine. Now that this one, if I take, say that I cross J, what will be that? This is the magnitude. This is that magnitude 1. Now what is the angle? 90 degree, right?
90.
I'm going to draw over. Here. I have to use that. Say this is my I head. This is, say I choose this is the J head, and this is the K head. Then angle is 90 degree between the I and J, right? Now what would be that eta head over here? So remember, I said you when you use that A cross B equal magnitude of A, magnitude of V sine theta into eta head, that eta head must be perpendicular to both vector A and B separately. But it doesn't require that the A and B would be perpendicular each other. Sometimes it would be, but sometimes not. But the eta head will be always perpendicular to the vector A and B for this cross product. So then what would be the vector over here? This quantity is going to give me basically that 1, right? Because sine 90 basically the 1. Then 1 into 1 is going to be the 1. Then what would be the vector, that direction of that unit vector? That's going to be the perpendicular on both I and J. It has only the possibility that K is going to be the perpendicular on that both vector I and J, right? Am I right?
Yes, sir.
Then this I cross J is going to be the K. This is one more way actually we can find out the direction of I cross J. We have to use the right hand rule. I hope all of you know that right hand rule. What's that rule? I'll put my index finger in the first vector and I'm going to rotate all of the vector towards the second vector. Then my thumb will give me the direction of that resultant vector. You can apply, put your index finger towards the first vector I and rotate the rest of the finger towards the second vector, vector J. Then thumb direction would be the resultant vector. If you do that, then you will find out that direction of the thumb would be towards the direction of the K. And the K is perpendicular to both I and J. So that's why we can say that the I cross J would be basically that K. You say I cross J would be basically the K. What about, say, if I say that J cross K?
I.
This will be the I.
I.
Yeah. What about if I say that K cross I?
J.
J.
That's going to be the J. Right, look at this. I use a cyclic order. This is called the cyclic order basically. Say if I take, say that I, J, and K, I use in that technique to find out this thing. Basically, if I take that I cross J, I'll find out that plus K because I'm moving to the counterclockwise. That is the convention also. If you move from positive x-axis counterclockwise, we'll use that positive. But if you move to the clockwise direction, that's will be the negative. We will also follow this convention over here. So that's why if I write down the I cross J would be the plus K, J cross K, that's with the minus, the plus I, K cross I, that's going to be the plus J. What if I write down in the reverse way, if I write down, say that J cross I, right? J cross I means right now I'm moving to, I'm using say different color. Say J cross I means I'm moving to the clockwise direction right now, right? J cross I. First vector is the J, second vector is the I. Then it will be the basically that minus K because I'm moving to the clockwise direction. Same way if you say that K cross J, that's going to be the minus I. If you say that I cross K, that's going to be that minus J. So this is actually that properties of this unit vector, whether there is a dot or the cross product. We are going to use these properties of this unit vector to find out the multiplication with the dot and the cross product. Using that idea, we'll find out this thing. So fine. Any question over here?
No, sir.
No, sir.
Fine. Let's talk about the vector component. Still, we basically doing this. This is actually the component. Say I have to find out. Say I have a vector, two vectors. Say this is the vector A, and say this is the, or I should use that one vector first, then I will use 2 or 3 vector. Basically the 2 vector. Say I first took that from the axis. Say this is my x-axis, this is my y-axis, and say I have a vector. Use the different color. So this is the vector A. And say that vector create an angle towards that positive x-axis is theta. And I'm going to find out the component of that vector. Components, that's mean the shadow of vector in the x and y direction, right? So if I put on a light into that vector, that will give you a shadow on the x-axis actually, that we can find. Say this would be the basically that shadow of this one, and I'm going to say this is actually that ax. I write down the subscripts as x because this is the x component, and this one I should say is basically that ay. These are the component. I'm going to find out that component, and we already talked about this thing, right? If I multiply by the I head and this I multiply by the z head, then these two vector actually head to tail connection, then we express that vector actually a equal could be ax I head plus ay z head, right? We already talked about this thing using the vector triangle law. Now my target is to find out what is ax and the ay. So that we can find out using basically say trigonometric definition, since it's a right angle triangle, right? So this angle is 90, this angle is theta. I'm saying that this is actually that ax, this is actually that a, and this is actually that ay. And this angle, you can say that this angle would be 90 degree minus theta, right? Now remember, when you're going to find out the component of a vector, always you have to take the cosine ratio, never take the sine ratio. Sine ratio is basically give you automatically if the axes are perpendicular to each other, right? I'm going to show you how. Say I'm going to find out the ax, which for this right angle triangle I can say consider this is my base, right? And this is my hypotenuse. Then by the definition of the trigonometry, we can write down the cos theta would be base, which is ax, divided by hypotenuse. Then I'll find out that ax would be a cos theta, right? So that's how actually we find out that component of a vector a cos theta. Fine. What about ay? Now the case for the ay, now I will reverse it. Now I will consider this ay is my base, and this one is again the hypotenuse, right? So then I will use same definition. Say cos, now my theta is 90 degree minus theta would be base. Base is ay right now for that case, and the hypotenuse is basically the a. And by the trigonometric properties, cos of 90 degree theta is basically the sine theta, right? Is going to the
Yes, sir.
sine theta is going to be the ay divided by a. That's how I will find out this ay will be that a sine theta. It will be happen if the axes are basically the perpendicular to each other. If the axis is not perpendicular, then you are not going to find out the sine component. It's going to be different, right? So that's why it's better to take always to the cosine ratio with the angle. Then you will find out the actual result. Otherwise, sometimes it will be the wrong actually. So that's why it is safe to use the cosine ratio always to take the component of a vector towards some direction. Fine. Say now I have two vectors. Say this is my vector A, and say this is my vector B, and they create an angle a theta in between them. Please guys, if you don't talk, mute your microphone. Yeah, thank you. So now So I want to find out the component of vector. I should make it bigger. So component of vector A towards the direction of vector B. So how I'm going to find out? I have to take the component of vector A towards the direction of vector B, or vice versa. I want to find out the component of vector B along the direction of vector A. So what I'm going to do that, so first I'm going to find out the component of vector B along the direction of vector A. So I'm going to take the projection, right? Projection of vector B or the shadow. So this is to be actually that I can say that component of vector B along the direction of vector A, right? If you put on a light, you will find out the shadow of vector B would be towards that direction, which would be that length actually. And this one, how I'm going to find out? It would be basically that B cosine theta. Can I say that one?
Yes.
Do you understand my point? And
Yes, sir.
by the same analogy, I can say if I take that component of A along the direction of vector B, which would be my that one, this is to be also that A cos theta. If it is,
Yeah.
then I can say this one would be basically that A sine theta, which is perpendicular to the direction of vector B. A cosine theta is the component of vector A along the direction of vector B. And A sine theta is the component of vector A perpendicular to the direction of the vector B. Do you understand my point?
Yeah.
I give you a lot of
Yes, sir.
information over here. So A cosine theta is the component of vector A along the direction of vector B. A sine theta is the component of vector A perpendicular to the direction of the vector B. Same way, we can also say that B cosine theta actually that component of vector B along the direction of vector A. And this one would be basically that B sine theta is the component of vector B perpendicular to the direction of vector A. We write down the B sine theta and A sine theta because they are perpendicular to each other direction. So that's why this angle we can find out, that angle we can find out in that form. It will be the perpendicular component will be the sine theta over here. So that's how actually we find out that component of a vector. With any axis and any vector we can find out. For that one, I just have to know the angle between the two vectors. Then I will be able to find out that component of that vector. Whether is it 1D, 2D, and the 3D, it would be easier for you to find out that component of that vector. You'll find that component, sometimes we also express in terms of basically that polar coordinate, right? Polar coordinate. I just give you the idea of this polar coordinate actually. So because we use that one to find out, say, this is my Cartesian coordinate, say X and the Y, and say I have a position vector. So this is actually that vector R, and it's create an angle, the theta. Then we find out the relation between these two things actually, R and theta, with that Cartesian coordinate system. Say we can say this, the position of that one would be X, or the coordinate, right? I know, so this is would be my X and this is would be that Y. Then I'm going to find out that R and theta. So that's when I'm going to make the relation between the Cartesian coordinate and the polar coordinate. I hope you can find out this one, right? Because over here, this X you can write down. X would be basically that R cos theta, right? Because the R cos theta actually the projection on that one, and the Y would be basically that r sine theta.
R sine theta.
Now we can square this one, x square, y square, it would be r square, sine square theta plus cos square theta, basically sine square theta plus cos square theta, basically the one, right? Then I can write down the r square would be basically x square, y square. And we find out r would be in that case actually that x square plus y square. And that's how we find out the magnitude of a vector. It's a two-dimensional or three-dimensional case. And the angle, we find out, say that theta, we can take the ratio of these two one. So, or tan theta, if you take that, tan theta would be basically that y by x. Remember, when you take the tan theta, or the theta, when you use that formula, theta inverse y by x, we refer that we are moving from x to y direction. And this formula always give you from nearest x to y. When I'm saying that, there is a reason. So what does it mean?
Y to x?
Yeah, you can do that. It will be, you can also find out. So it will be tan inverse x by y. If you do that, then that would be that angle. If you take that y by x. And in that case, the angle will be negative, basically. Because why? That's the convention. Say, if I saying that a particle is moving towards some direction, making a 30-degree angle. And if I say that only, can you precisely say the which direction it is moving? Right.
X to y. Oh, okay. Yeah.
So what will be the case actually? Say, what are the possibilities if I say that it's making a 30-degree? It would be possibility, this could be the 30-degree. It could be possibility, it could be create a 30-degree over here. It could be possibility is create a 30-degree over here. Or it could be possibility the 30-degree also over here. Right? There are a lot of possibility 30-degree over here. So to overcome this confusion, actually, we use the angle. If you say that the 30-degree, I always assume that you are counting the angle from positive x-axis, counterclockwise is positive. So if you say the 30-degree, instantaneously I will assume that the particle in the first quadrant, right? This is the first quadrant actually, which is create that 30-degree with the positive x-axis. That's the convention actually. They will follow. So we'll also follow that one to overcome that confusion actually.
Okay, sir.
So there will be some case, say I find out a vector. Say I have a vector like that. Say that the 5i hat plus 5j hat. What would be the angle of this vector? Can anyone say what would be the angle of this vector?
Tan inverse 1.
Yeah, that's going to be the 45.
45.
Right?
Yes.
What about if I say that minus 5 plus 5j?
Minus 45 degree.
Minus 45 degree. Yeah. So what is minus?
Because it's clockwise.
It's a clockwise. Fine. So there will be two possibility of the clockwise. Right. I said you if you use that tan inverse x by y, so you are referring from x-axis.
Yeah.
Right. So if I say the vector is over here, this angle, if you say that 45, it could be minus 45. Right? It's a clockwise.
Yeah.
And that could be possibility also. This is could be also minus 45. It's also the clockwise direction.
Yes.
Right. So which one I will assume? The particle either moving towards that direction or that direction. If you say the minus 45, there could be two possibilities, right? It could be in the second quadrant and it could be in the fourth quadrant.
Yeah.
So then what would be the actual result or actual direction? So in that, yeah, someone want to say something. Go ahead.
So I think it will be in the second quadrant.
Second quadrant, yeah, that's right. This will be the second quadrant. So if you say that minus 45 degree, then you have to mention from negative x-axis, then I can precisely measure that one. Or you have to say that this angle, so 180 degree minus 45, right? That's going to be the 135. If you say minus 45 from negative x-axis, that's right. Or you can say that 135 degree, which is you're counting from positive x-axis counterclockwise. This one comes actually 180 degree minus 45. Then I can precisely assume that it would be in the second quadrant. This is a very important thing. So what about, see if I say minus 5, sorry, minus 5j,
45 degrees.
yes, 45 degrees. So that's when you are saying that it is in the first quadrant.
It's in the
Yes.
third quadrant.
It's in the third quadrant, yes.
So it should be in the third quadrant, right?
It should be in the third quadrant, yes. So definitely you have to closely observe the vector control. Look at this. If you use that 10 inverse minus 5 divided by minus 5, that numerical value become basically the positive 1. And the calculator will give you basically the 45 degree. He's right. It's right. But it cannot say that which axis it would be. Basically, I said you this one will count down always from nearest x to y. When you write down, this is your negative x component, this is actually your negative y component, then it will find out that angle, and nearest x is that one, right? Nearest x to y. That formula I said you always give you from nearest x to y. Tan inverse y by x. You are referring from nearest x to y. It doesn't care about for this plus x-axis. It will, since the minus x-axis is nearest to it, so that's why it will give you that 45 degree. And sometimes that's why I say the calculator is a stupid device actually. So it cannot say you the actual result. If you say that 45 degree, then you have to mention negative x-axis counterclockwise 45 degree, or you have to add 180 degree plus 45, right? Then the actual angle would be the 225 degree. If you say the 45 only, then I will assume that basically the particle actually the moving in the first quadrant, but it is not. It is actually in the third quadrant, totally in the opposite direction. So that's why you have to closely observe the component, the which direction it is basically. What about say this one? If I say that is plus 5i minus 5j, what will be that angle? This angle is going to be that minus tan inverse 1, right? Is going to be that minus
It will be in the
45
fourth
degree.
quadrant, right?
It will be in the fourth quadrant, definitely. So then it is minus 45 is right, because it's moving to the positive x-axis clockwise. That's why it's a minus 45 is acceptable. If you say that minus 45, I will assume that the particle actually in the fourth quadrant. So that's why this component of this vector in the two-dimensional case is very important to locate the particle actual, to find out the direction of the particle right way. So be careful about this component to find out that direction of that vector.
Sir, why did you get extreme from 35? From which axis it is going? I mean the angles.
I didn't get you guys. You two actually that make a destructive interference. Two guys talk at the same time, the waves is going to be the destructive. The resultant will be the 0. So that's why I didn't hear you guys. Say one by one.
Sir, can you just explain me the third one again?
So third one,
Minus 5 I minus 5 J.
exactly. Wait, okay, fine. Look at this. So my vector is minus 5 I head minus 5 z head, right? If I write down my formula, theta equal tan inverse y by x, my y component is minus 5 and j component is also that minus 5. So minus 5 is going to be the plus 1. Then I'll find out tan inverse 1 that calculator will directly give you, say +1, so your angle will be the 45. But the angle, if you say the 45, I say you, when you say the mention the angle, it will be referred from positive x-axis counterclockwise. That's the convention.
Yes.
Right? But so that calculator is count from nearest x to y. So that's why it actually that angle, and it is also counterclockwise, so that's why it's give you positive. But actual angle, to find out, I have to add this 180 degree. So that's mean 180 plus 45, that's going to be the 225 degree. If you say the 45 degree, then you have to mention from negative x-axis counterclockwise 45 degree. Then it will give you actual direction, right? If
Or
you
we
say
can
that,
write 2 to 5 degree.
yeah, or you can say that 2 to 5 degree, then I can locate the particle right way.
Okay, sir.
Yes, any more question? Fine, let's talk about the three-dimensional case. How I'm going to find out that? Oh, okay, that's not required. When I'm going to introduce that product of vector, then you can find out. So in between the angle between, so multiplication of the vector. Right now I'm going to talk about multiplication of vectors. There are two ways we can find out the multiplication. One is called basically that dot product, or sometimes it's known as scalar product, or sometimes it also called that inner product. That inner product term we use actually in the case of quantum mechanics or classical mechanics. Second one is called that cross product, or sorry, vector product, or this is called the outer product also. In the field of quantum mechanics, they use this notation also, outer product and inner product. Fine. Now, first I'm going to talk about the dot product. There are two ways we can also find out this dot product. First one, we'll write, say that A dot B. That's, I hope you know that AX BX plus AY BY plus AZ BZ, right? This is one way you can find out the dot product. And how it's become is basically you can use that the properties of the unitary vector. So I'm going to show one line so that you can understand. So this is actually that A, B. I write down the A vector AX I head, AY J head plus AZ K head. This is my vector A. And the second vector BX I head, BY Z head, and BZ K head. Now what I'm going to do, I'm going to multiply by this AX I head component with the rest of this V vector, and with the AZ and rest of these three part of this V vector. If I do that, it's basically the linear algebra. So we express in that. Look at this. I'll write down the AX BX I dot I, right, plus AX BY I dot J plus AY, sorry, AX BZ I dot K. What I did, I just multiply this AX I term with the rest of the v vector, and plus dot dot. You can do in that way. Why I'm doing that? So look at this. I dot I know that that will be sub dot, but I dot j, that part is going to be the 0. This I dot k is also going to be that 0, right? Similarly, if you multiply with that I dot j with that rest of the part of the vector b, this I dot I j dot I will be the 0, j dot j will be the subbyte, and j dot k will be basically the 0. Same way the az component. That means I will find out only in that case a dot b would be basically that ax bx plus ay by plus az bz, right? That's how this formula become over here. You can prove that by yourself. Do that rest of the part, you can find out. So this would be actually your dot product between the two vector. If you know that the vector properly, then you can, using that one, you will find out that dot product of these two vectors. And it's basically the scalar quantity, right? You will find out only the magnitude of this one.
So could you explain the second step?
This one?
With the two arrows, the second step.
Oh, this one, basically the I write down the, it should be the 0. Why? I write down the 0. Are you asking for why it is 0 or how I write down that one? That is your question.
Yes, sir.
So I write basically, I multiply with this axi vector with the every component of the v vector. Look at this, axi dot bxi. So that's when I separate ax bx I dot I. Then axi with byj. I write down ax by I dot j. axi dot bzk. Then I separate ax bx I dot k. I use the properties of the unitary vector over here. I know that I dot I is basically that 1, right? But I dot j is basically would be the 0. So that's why I cancel out. This would be the 0. By the similar explanation, I dot k would be basically the 0. So that's mean this ax by ax bz will be cancelled out each other. So that's mean the similar identity ax bx will be the survive. Same thing you can write down from ay by and az vz. So that's how it's become that one. A dot b is basically become ax bx ay by and az vz. Is it clear?
Yes, sir. Thank you.
By the same analogy, say if I take that a dot a, what would be that? So I'm in that case, I'm writing, say that axi plus, it's called the vector product itself, the cross product. A hat, right, dot x I hat ay z hat plus az k hat. What I can write a dot a,
A mod square.
a square, a mod square. Definitely. Then the right hand term would be basically that a x square plus a y square,
A y square.
plus a z square. I neglect that other term, right? So I dot I is basically the 1, but I dot j is basically the 0. So I neglect that part. So then we can say that that's how actually you find out the magnitude of a three-dimensional case. You find out the magnitude is become a x square plus a y square plus a z square. That's how actually you can use to find out the magnitude, which is actually the scalar product. From a scalar product you can find out that way. Fine.
Sir,
Yeah.
sir, in the videos we have seen a term called norm. What is that? Can you please explain that?
So norm actually the is a which one you are talking about? Which I didn't go through that one.
There's a term called norm. I don't know.
That's probably he indicate about that normal vector perpendicular to that actually. Could be, I don't know. Can you mention the which vector he mentioned that one, or which lecture?
I don't remember the exact lecture name. Okay, I'll inform you of that.
Okay,
later.
fine. If you can inform me, then I can give you the idea.
Yeah, sure.
Yeah, fine. So second
No,
process,
lecture 1.
lecture 1, in which
Yes.
video?
The
In
third
lecture-
one.
Okay, fine. I will see that one and inform you.
Okay, sir.
So the second one, we find out, say that A dot B is basically is a famous formula, AB cosine theta, right? My time is running out. Anyway, this one is also could be the proof. I'm not going to prove that one. You can find out. This is, you have to use a geometric idea to prove that one, AB cosine theta. We use that formula to find out the angle between that vector. Always, if you want to find out that angle between the two vectors, always use this formula. This is very useful formula. Never use A cross B equal to AB sine theta, because sometimes that's give you the wrong answer. But A cross B is always give you that actual answer if you know the angle between two vector. So, and remember, since this is basically the scalar quantity, so that's why we can say that this product of A dot B, it could be greater than 0, it could be equal to the 0, and it could be also the less than 0. So that's mean the number could be, since A dot B is scalar quantity, it will give you some number. It could be positive number, it could be negative number, and it could be also that 0 basically. And that depends on the angle. What is the angle? So if you say the angle is, say, I have an angle which is, say, that greater than 0 theta, and it is less than 90, you will find out the positive value. If the theta is basically the 90, then you will find out the 0. If you say that theta is greater than 90 and less than 270, so that's mean 3 pi by 2, then you will find out that the angle will be basically the A dot B will be basically that negative. That's how actually you find out that component of a vector or the dot product. Let's talk about the second one. So cross product. Cross product. There are also two ways we find out the cross product. One, say, we can express, this is, say, we have a two vector I should write. So the vector A is AX I hat plus AY J hat plus AZ K hat, and vector B is BX I hat BY Z hat plus BZ K hat. Then A cross B, we can write two way. One is called the determinant process. I hope you are familiar with this one. I, Z, K, and this is the coefficient of vector A, AX, AY, or AZ, or the component of vector A along the X, Y, and Z axis. In the mathematical term, we talk about this is the coefficient of this equation. It's a linear equation basically, and this is that BX, BY, and the BZ, right? That's how we express that vector. And
Sir,
how
I
we
don't
going to,
get how this works.
how this works, or how I write down that one?
This entire thing, like the video said that this is a useful mnemonic, but I don't get this. What is this?
So this is AZ, and this is actually the BZ. This is actually the technique. The you are going to represent, say, that some linear equation to solve using this. It's also come from the Cramer's rule basically. You will understand that. Yeah.
So it's like a matrix. We find the determinant of the matrix. It's kind of like that, right?
Exactly.
So
Is this the same thing we did for a 2D determinant?
Exactly the same thing. So because
So we just
right.
remember, mathematics is a mathematician is my very good friend actually. Without mathematician, I cannot move one a single step. And that's why I like the mathematician most. Because remember, a very good physicist is a very good mathematician.
Thank you, sir.
Yeah, I like the mathematics very much.
So,
Because that's
so I have a-
like two. Yeah, Albert. That's why I
so
always care about the Albert.
so
You know?
I read somewhere that you can only
Sir,
find cross
also
product.
me in mathematics department.
Yes, sorry, I didn't get you. You guys again making the destructive interference.
So I was like, I read somewhere we can only find cross products for 3-dimensional vectors, and we can't do that for 2-dimensional vectors. How true is it?
Yeah, sometime you could find out because the direction would be basically the case. Actually, if you say some component is 0, right over here, you'll find out the other two component. Actually, it could be also find out because the target of the cross product is basically the two. One is we have to find out the magnitude, and you have to also find out the direction.
Okay, sir.
Yes, next question. Yeah, can I proceed?
Yes, sir.
Yes, sir.
Yeah, thank you very much. Now, how this is going to find out? I know some of you basically they make a mistake over here to write down because there is a plus minus issue, right? I know what you did actually. You take that a bar over there. They teach you in the math class probably. Then you write, say that this is the I component I'm taking the product with that fast, and interchange is that one, right? We write down that AY BZ minus AZ BY, right? And plus, I write down the plus. There is a reason. I'll say with that on why I do that. I do in my way. Mathematicians do is in their way. But since I'm a physicist, I use that convention actually. Why I'm saying that? So X, Y, and Z, I write in that form. If I move to the counterclockwise, I'll take the result is positive. If I move to the clockwise, I'll take the result will be the negative. I use that convention also over here. I'll show you. Look at this. If I write this thing would be that AZ BX minus AX BZ plus K hat is AX BY minus AY BX, right? This is the formula. Now the question is how I'm writing that one. Look at this. When I'm writing the ith component, so that's when I'm taking that X component, right? I'll forget about that thing. I'll keep it that intact. I'll first take, I will move from Y to Z. I write down, look at this, AY BZ. Since I'm moving to the counterclockwise, so that's a positive. But if I move second line, I write AZ BY. That's why I'm moving to the clockwise direction. So that's why it's a negative. Right. Now for the second one, I take the Y component is, I'm going to find out the Y component. That would be my Z and X. I will start AZ into BX. It's a counterclockwise direction. I find out the positive. Then AX BZ. I'm moving to the clockwise direction. So that's why it's a negative over there. What about the third one? The third one for the Z, I will keep in that. So XY, I'll write down that AX BY minus AY BX, because second time I'm moving to the clockwise direction. In some book, they use that one is basically the negative. So AZ BY minus, in that case, AX BZ minus is going to be the AZ BX Z hat plus K hat will be the remain same, AX BY minus AY BX, right? Probably the second one, this one is familiar with you. Most of the book, they use the minus sign over here. But why they use the minus sign? Because of that reason. If you move to the counterclockwise direction, that would be a positive. If you move to the clockwise direction, that's with the negative. This is the reason why they sometimes use the plus and minus sign, because if you multiply this minus sign, that's going to be the plus. This is my equation over here. I use it that way. I don't memorize. I'm not recommended you to memorize this thing, because if you do the memorize this thing, definitely you will make a mistake over here. So please don't try to memorize this thing actually. So this is actually the determinant process you can find out. The second one, which is we already talked about, say this is that A cross B would be basically the magnitude of A is the magnitude of B into sine theta and the eta hat, right? This theta hat is going to the perpendicular in both A and B basically. That should be basically that to find out that second procedure of this the cross product. And this one is also we can find out, say whether it's basically the positive, it could be also greater than positive equal to the 0, and it would be also the negative sometime. And this would be greater than 0 is a positive number if the theta is greater than 0 and less than pi. If theta is equal to basically 0 or pi is called basically that n pi, 0, pi, or twice pi. In that case, we can write down this is actually that theta actually the n pi, which n actually there is from 0, 1, 2, 3. It's a natural number. And less than 0 would be if theta is greater than pi and less than 2 pi. That's how actually we can find out whether it's going to the positive, negative, and also the equal to the 0. Okay, fine. Let's find out the physical significance of this cross product. Can you say what is the physical significance of this A cross B? It's a very important thing. Right now we are coming to the real life actually. What is the application where we use this vector in our real life? Can anyone say?
Sir, I'm not sure, but I think it was used in engineering for
always in science. Remember, you can never neglect the vector. I said in the first class probably, say you are here at the Brack University. Why? At the end of the 4 year, you are going to, someone is going to be the engineer, someone going to be the scientist, right? So that's when you have some target. You have some target. So that's why you are over here. So that target is your vector. That is your target is also the vector. This is the most usable thing in our real life case actually. So you cannot never neglect the vector. If you do that, then you cannot reach your destination.
Sir, what will I be? Mathematician, like after finishing maths?
You are from math department?
Yes.
Depends on where you end up.
Exactly, where you end up.
Oh, no.
Fine, look at this. This A cross B is always give you basically that area. Can someone define, how do we define the area? Which formula actually you use to find out the area? Which formula you memorize?
This area of what?
Length into
Of what
breadth.
shape?
Yeah, exactly. Who said that? Length into breadth, right?
Yeah.
Did you ever use instead of cross sign, say that length dot breadth? When you memorize, you never use the dot over there, right? You use the cross.
Yeah. Yeah.
Why? Because area is a vector. So that's why you use the cross sign over there. Area is always vector. Remember this thing. Say if you have a
Area
vector,
is a vector?
of course, area is a vector. If you have, say, the two vector which is represent one length, and the second vector is the B, or I should write down the B in the left side, then it would be easier for you. So I'm going to show you the direction also, that area, what would be that. Say, this is actually the vector V. Then if I say that A cross B. So I'm going to write down that one, right? Which is basically give you the area of that region. And what would be the direction of this area? To find out that area, direction of the area, you have to use that right-hand rule. If you put your forefinger towards or index finger toward that direction and you rotate that towards second vector towards the B, then your thumb would be basically the upward direction. So that's why this area would be perpendicular to that surface. If you say that A cross B would be upward direction, but say I want to find out, say that B cross A, what would be that? What would be the direction in that case? If you put your index finger in the first vector towards the A, then if you rotate that towards the second vector of your finger, then the thumb is upward. So that's why this eta head is the upward over here. But in the second case, for the second case, B cross A, if you put your index finger toward that direction and rotate towards that direction, then the eta would be downward direction. That's why we can say that B cross A would be the minus eta head. Area is always perpendicular to the surface, direction of the area. Remember this thing, it's a very good point. You have to use this one. The area of a surface, it will be always perpendicular to that surface. The point you are indicating. If the surface is homogeneous, it's a curved surface, then you have to locate a point. Say if you have a curved surface, so I'm going to find out the area over here, it should be toward that direction. If I find out the area at that point, that should be the towards that direction. So this, remember this thing, so that's why this A cross B always give you that area. It's a vector.
Sir, by saying upward, you mean out of the page, right?
Yeah, it's out of the page actually.
Okay.
It's dependent actually which orientation you keep that your pace. So if you think about you keep a vector in your screen, whether it's a laptop or in the desktop computer, if you keep your two vector in that screen, then the area of that two vector will be either out of the screen or into the screen.
Okay.
Okay, fine. Can you say what would be that one? Say that A cross B, say I multiply with another vector is the C. What would be the physical significance or physical dimension of this quantity? First, say whether this quantity is a vector or a scalar. This quantity will give you a vector or a scalar.
A scalar. A scalar.
Scalar.
Very good. It will be a scalar.
Scalar.
Why is it scalar?
Yes.
Look at this. If you take that B cross A cross B, that will give you a vector, right? Say that vector actually say the D.
Right.
With that D, if I take that dot product with the C, so definitely it's a dot product. It's to be scalar. I'll find out some number over there.
Right,
so that's
right.
why this total quantity is basically that a scalar quantity.
Yes, sir.
Yes, sir.
Now, what would be the physical dimension or physical significance of this quantity? What I will get?
A volume, 3-dimensional.
It's a volume. Very good. It's a volume, and volume is a scalar quantity, right?
Yes, sir.
So A cross B dot C always give you a volume, and it doesn't care about, say you have a cube or a room, you are in a room, you define say one vector in that way, A cross B, that will give you the area of that your surface. Now with that area, if you multiply one more dimension with that C, that is going to give you that area, volume of this room, right?
Yeah.
This is going to give you that volume of this cube or the room, whatever you say. And what will happen? Say if I write down, say that B cross C dot A.
The value will be same, right? Because the volume.
The value will be the same. Say volume is the same. So that's when I can write is the A cross B dot C equal to that B cross C dot A, or A cross C dot B is going to the same quantity because it's a volume. If someone asks me find out the A cross B dot C, and the second time they ask me find out the B cross C dot A, you can say the result is going to be the same because this is a scalar quantity. It's significant, it's a volume, so volume would be the remain same of a object. If you, unless you change the dimension, unless you change the length of this vector, then these three quantity will be the give you the same result. Fine. So this is actually, we can use that. It's called the triple product, vector triple product. There is one more case, actually, the triple product. We use, say that A cross B is a C. What will be that? Will be the vector or scalar? This one?
Vector.
It's a vector, right? And there's a rule is called the
vector.
It definitely is a vector. Yeah. So we use, it's called a rule actually. Say B A dot C minus C into A dot B. If it's the cross product, cross of triple product, then you can find out using that formula. It's called the back cap rule. Look at this. BAC is a back and CAB is called the cap. We use that formula actually, back cap rule. Mathematician is a very nice guys. They create a lot of formula for us actually. We use that in our real life. So that's why we use that. This formula actually find out some mathematician. We use that from back cap actually. Our job to apply this rule actually in our real life. So that's how actually we find out the dot product and the cross product. If it is 2 vector, 3 vector, 4 vector, whatever the case, you can multiply in that way actually. So whether it's a dot product or cross product, you can find out in step by step in that way. And remember, there are some properties actually we talk about. This is actually A dot B. Say if I write, say that, what about A dot B? We can also write down that B dot A. Right? It will be the same because this is ultimately a number, a scalar quantity. But remember that A cross B not equal to that B cross A. It's never going to be the same. It's with two different directions, right? I give you that idea. If you say that A cross
minus B.
Minus, yeah, exactly. A, say if you say that this is your A, this is your B, A cross B, if it is upward, then the B cross A will be the downward. So this is actually the direction of A cross V, and this will be the direction of V cross A. So that's why we can write, say that A cross B actually minus B cross A. It's called the anti-symmetric actually in the case of metric operation. The dot product actually is symmetric, but the cross product is anti-symmetric. We talk about this thing in the case of matrix operation or metric representation of the vector. And there are, if you multiply, say that these are the properties of the, say I have, say that in A dot MB, say N and M basically some scalar quantity, scalar num is basically the number, then we can represent NM A dot B. Same thing also true for the cross product, say this cross MB, we can write N into M A cross B. These are the properties. Say there are some distributive properties. Say I have A into, say that B plus C, or you can write down the dot. I can write AB plus AC. That's are the properties, you know, that we can use this thing in the case of that. Yeah, do you have any question over here?
No, sir.
No, sir.
No, sir.
Then your class time is over for today. I have one more idea actually that also I'm going to talk about in the case of the, you will find out some idea over there. So in the case of sample problem, already they asked you probably in some case. I'm going to give you that idea. So this is X, Y, and Z axis. Say I have a, can I take 5 minutes more?
Sure.
Yes. Can you give me 5 minutes more, or you have a class?
Yes, yes, sir, you can.
Yes,
Okay,
yes.
fine. Okay, fine.
Sure,
Then
sir.
I'm going. Okay, fine. So, do any of you have a class at 2 p.m.?
No, sir.
No, sir.
No, sir.
No, sir.
Okay, thank you very much. I just talked about one topic over here. So this is going to be helpful for problem solving. Say, I have this vector. A. Say that vector given in a case, say that A is 3i plus 4j plus 5k. That's given. So then they ask me, find out the angle of this vector A is going to create with the z-axis. Just only that one. So I said, I just know the vector, and they asked me to find out the angle between z-axis and vector A. How I'm going to find out that one? Only this information. I have only the vector A, and they asked me to find out the angle between that vector A and the z-axis, or any axis. They can say that find that x-axis or the y-axis. Which formula I'm going to use to find out that one? Or which formula came into your mind to solve this problem?
The dot product formula.
Dot product, yeah, fine. So in that case, if you want to use the dot product, A dot B would be AB cos theta, right? But
Yes.
then I need the second vector, would be the B, right? I can use that formula, right? But I have to modify that one. I'll write, instead of B, I'll write the K hat, because I know there is a unit vector in the direction of that z-axis, which is basically that K hat. So then I can write out magnitude of A. I can find out from that equation, and the magnitude of the K, that is 1. I know that, and cos theta. My target is to find out the theta, which is the angle between the z-axis and that vector A. Now, fine. If I write down, look at this, 3i plus 4j plus 5k into k hat. And what is the magnitude? It should be 9, 16, and 25, 50, right? Magnitude would be probably
5 root 2.
5 root 2, exactly, yes. Because root 50 is a 5 root 2, and the magnitude of k is 1, and the cos theta, right? So I know I dot k is 0, z dot k is 0, so k dot k will be the 1. I'll find out the 5 over there, equal to 5 root 2 cos theta is going to cancel out. Then I can find out, say, cos theta basically 1 over root 2, right? In that case, is the theta is going to the 45, right? Am I right? 1 over root 2 is 45 probably. Let me check that.
Yes, yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, yes, 45, yeah. So that's how actually we can find out that angle between that two vector with any axis they want to know. You can use that formula. That's why I say that this is a very powerful formula to find out the angle between the two vector. Then I can find out with any axis, x-axis, y-axis, or any axis they want. I can find out using that formula.
Sir, why didn't we use the cross product?
So cross product is not always give you the actual result actually, because remember, so the product is say that A cross B actually that AB sine theta head, right? So sometimes if these two A cross B actually say that in different plane, then you cannot find out that exact result. Sometimes it will give you the wrong answer actually. So that's why you never try to use this A cross B. It gives sometimes the wrong answer actually. Sometimes it's what, but always it doesn't give you the actual result. Sometimes gives you the wrong answer. So that's why it's better to use that A dot B dot product to find out the angle between the two vectors. Okay, thank you very much, guys. I'm done today.
Sir,
Yes,
when we face problems, sir, when we
Yes.
face problems while solving the quizzes, when do we ask you for, like, you know,
For quizzes?
explain?
You're asking for help for the quizzes.
Yeah,
Yeah, you can. We are planning to explain that result of these quizzes. I hope you don't have to ask me that answer. We are planning to give you the explanation of the answer of the quizzes. So
Okay.
then
So
I
where
hope
can
you
we
will
get
be
the
able to solve.
sample problems?
Sample problem you will find out in the BUX. We already uploaded the suggested problem from reference
No,
group.
I mean ones for practice, ones that we can practice ourselves.
Yeah, that's the thing I'm talking about. Suggested problem for practice from Reasoning Helida Walker 10th edition book.
Okay.
Or you can go through the sample problem tutorial video actually. We already uploaded after the lecture actually. You'll find out sample problem or tutorial. Let me allow you to show that one. I hope that is. Oh, suggested program. Why is that? They did not upload it. I'm sorry. Probably they should upload that one. Okay, I will talk to them actually to upload it. You will find out that sample problem, practice problem, tutorial problem. I'll talk to that course coordinator of this one. I'm going to talk to him actually. Look at this. Can you see my screen?
Yes, sir.
Yes.
So this is actually the example or tutorial problem actually we uploaded. So this is your lecture 1. Probably there are 4. It's a 5 sample problem uploaded over here. This is for your lecture 1. What about the lecture 2? So this is lecture 1. And this is lecture 2. There are also the example and tutorial problem. Yeah, you will also find out some problem over here. I don't know how. It's a 20 minutes probably.
Sir,
20 minutes.
I had just one confusion from the quiz. Could you, like, explain it now?
Yeah,
Like,
sure.
you
Why
have
not?
CUX open in front of you. It's like the lecture 2 last quiz.
Lecture 2 last quiz. So you can do one thing actually. You can give me email. I cannot give you the answer over here. Those who didn't
Okay.
give the quizzes, it's simply wrong actually.
Sure, I'll send you the email.
Sir, I submitted all the quizzes.
All the quizzes, 1 and 2,
Yes, sir.
or
Yes,
all
same.
whole lecture.
Yes, sir.
Lecture
Yes,
1
I
to lecture
also
8.
I've
finished
done all the
that.
quizzes, lecture 1 and 2.
Yeah, most of us actually finished that, but there are some people who haven't finished yet. So yeah.
Exactly. So that's why I'm saying that. Give me email regarding that issue. I'll try to explain that one.
Okay, sir.